Hello, everyone. Hope everyone weathered the storm and after the rain as well. Good to have everyone back, and looking forward to get back to kind of a sense of normalcy. If you were affected by the storm and you couldn't get your homework done, you have electricity or whatnot, please let me know. Please don't take advantage of it as well. Just wanted to let you know. All right, so we're going to move on to chapter 5. Chapter 5 has to do with simulation modeling. So we'll do some simulation modeling, an intro to that as well today, and then we'll get into a little more complex situations on Wednesday. All right. So the agenda, I just want to throw out the announcement that your case study is due on Wednesday for the face-to-face class at 11:59 p.m. and then Thursday for the online class at 11:59 p.m. Your homework is due Monday, which is today, or today that I'm recording it, by 11:59. That's homework number 3. And you should have that done by now. It's been a while, so I'm not really going to be accepting any late work unless you were adversely affected by the hurricane. Okay. So again, in this chapter, we're going to do some simulation. We're going to do some Monte Carlo simulation, which is exactly what it sounds. It's basically simulation that was developed basically for gambling. Monte Carlo is a big gambling area in the Mediterranean. So that's what we're going to do. We're going to first go over some quick little things you'll need to know for the Monte Carlo simulation, the random number generator, and then we'll get into an example of flipping a coin and rolling a dice, and then more of a business-like example, a manufacturing example. All right, so let's get straight into it. We'll start by talking about the definition of simulation. Simulation is a descriptive technique that enables a decision maker to evaluate the behavior of a model under various conditions. They basically simulate complex situations. They're simple to use, and sometimes they're kind of hard to implement, but simple to use. They kind of play the if analysis. There are extensive software packages that actually do this, but they tend to be expensive, and then for small businesses, they don't really have that kind of money for it. So a lot of times they'll be using a spreadsheet like Excel or some other type of spreadsheet format. Much like everything in this class, the problem-solving process, we also have a simulation process. The first step, as always, is to identify the problem. The second step is to develop the simulation model. The third step is to test that model. The fourth step is develop the experiments. The fifth step is actually to run the simulation and then evaluate the results. And then 6 is pretty important. Repeat 4 and 5 until the results are satisfactory. That doesn't mean that you repeat it until you believe you have the right answer. It means you repeat it to have enough simulation or iterations in the process to give you a solution that you deem is necessary. Okay. So there's some advantages of simulation. It solves problems that are difficult or impossible to solve mathematically. It allows to actually experiment with an implementation without a risk of an adverse risk to implementing the system. It compresses time to show long-term effects, and it serves as a training tool for decision makers. So again, everything we do, it kind of serves as a training tool for decision makers in this class. This is just one of them. There's also some limitations of simulation. There's no really optimal solution. It's just going to model the process or model the decision that you're looking to make, but it's not going to give you an optimal solution like an actual number, but it'll give you a process to go through. Okay. The development of the model will be difficult. For the Monte Carlo simulations, they tend to be a little bit easier, but when we get into queuing, which we'll do on Wednesday and Thursday, those will be a little bit more difficult because there's multiple factors associated with those. Another one is the computer runtime may be substantial. So we'll deal with some complex simulation models, and if we run them 1,000 times, so if we have 1,000 iterations, it's going to take a lot of toll on your computer. Obviously, your computer right now that you're running, it will be fast enough. But if you're dealing with something that has a lot of different iterations, then it actually can adversely affect your computer. Okay. Monte Carlo simulation is only applicable to random systems, so it doesn't deal with things that are not random. So that's what we're going to deal with. Again, when you're dealing with card games or gambling, those are random unless someone is actually cheating. So those are what Monte Carlo kind of deals with there. So quick little tidbits before we get into building a Monte Carlo simulation model. The first one is you need to know how to generate a random number in Excel. It's very, very simple. You just use the formula RAND, so equals RAND and then close parentheses. It will give you a number between 0 and 1, which is obviously perfect for probabilities, because probabilities are between 0 and 1. Now, if you want a number between, say, 0 and 10, all you have to do is multiply the random number times 10. Okay, so I'll show you an example of that really quick here. So if I want a random number, again, very simple, equals RAND. That'll give you a random number, okay? Every time you click something or add something, it will change the random number. So a lot of times all the time when we do these examples and we do these Monte Carlo simulations, you will have a different setup, or same setup, but different output than me, because the random numbers of mine will be different than yours, okay? Now, if you want a random number between 0 and 10, again, just taking the equals RAND, then multiplying it by 10. Okay, that'll give you a random number between 0 and 10. And again, it will change every time you click on it. And that's kind of how we're going to deal with the random numbers. All right. So that's the random number generator. Some other formulas you'll need to know, and these are not really for today, but for a Wednesday. Normal distribution. If you want to put in a normal distributed number, it equals the formula equals norm.dist, and then you put in a number, a mean, and a standard deviation. It's going to give you a normal distributed number based upon a mean and a standard deviation. And then inverse, a normally inverse number is equal to norm.inverse. You put a probability, a mean, and a standard deviation. It's going to give you an inverse of a normal distributed number. Now, what we're going to do is we're actually having a formula on Wednesday and or Thursday when you watch the recording if you're online class. We're going to have a random normally distributed number. So that looks like this, equals norm.dist, parentheses random, parentheses, comma mean, comma standard deviation. Okay, and that's what that kind of looks like. We'll get to that on Wednesday. I just kind of wanted to give you a heads up before we get into that on Wednesday. Or if you're on the online class and you look at the recordings, it would be on Thursday. Okay. The other one is count if. Basically, it's going to give you, it's going to count a certain value in a number range. So if you have a number range and you want to count how many threes there are, so you write equals count if. You would select that entire range of numbers, comma 3, and it's going to actually count how many threes are in there. Okay. Again, count if, it helps count the number of values in a specific range. So pretty simple there. So let's get into Monte Carlo simulation. Monte Carlo simulation is a probabilistic simulation technique used when a process is a random component. So again, when we're dealing with gambling, obviously it is random, so that's why we're using Monte Carlo simulation. The process is pretty straightforward. You're going to identify a probability distribution. We're going to set up intervals of random numbers to match that probability distribution, and then we're going to obtain the random numbers using equals RAND, and then we're finally going to interpret the results. So here's some uses for Monte Carlo simulation, and your book gives you some really random ones. I don't know why. Maybe that has to do with the random numbers in Monte Carlo. I don't know. So one of the ones they give you are nuclear reactor designs. So basically, the engineers in nuclear reactors will actually use Monte Carlo simulation to find out the probabilities the reactor failing. So obviously that will be really small, and they can build a safer nuclear reactor that way. Radiation cancer therapies. Econometrics is what I've used in most. Stock index forecasting. Oil well exploration. Oil well exploration is an interesting one. An oil well drilling company will actually use a Monte Carlo simulation to figure out the probability of oil in a certain area, and they'll base their drilling maps upon that. A lot of money in oil well exploration, so if you understand Monte Carlo simulation, maybe you'll become an oil well explorer. Okay. Here is an example of Monte Carlo simulation. You have your probabilities, you have your cumulative probabilities, and then number of breakdowns or number of whatever output, and then you'll have your random numbers, and you'll have a VLOOKUP formula to look up those numbers, and that's basically the simulation in itself. Okay. Again, doesn't really mean something right now, but it'll mean when we get to this next example. So before we get into kind of a business example, let's just do a flipping a coin and rolling a die, which is a very good test question. Hint, hint. In fact, will have one like this on the test. So let's get out. Download on chapter 5. You'll have the Monte Carlo shell. You'll download that. And again, in this class, if you use the same format for these problems every time, more likely that you'll understand the process better. So save this format, and we'll just keep using it over and over just to make it easier for everyone. And it's not the best. It's not. I think it's the best way to do it. But again, if you think you do a better way and you want to do it your way, that's totally fine. This is just the way I think about it. All right. So it looks like this. Again, we have our probability. We have our lower range probability. We have a cumulative, and then we have a payoff. This says simulated currency value. That's just because I used it for a different example. This could mean, in this case, we're doing a coin flip. So let's do heads / tails. Okay. All right. So probabilities. Again, probabilities of heads and tails on a coin is obviously 0.5, 0.5. Those are the probabilities. They have to add up to 1 as usual. Here you're going to put your lower range probability. So you always start at 0. Okay. Then you go up by the probability of the first payoff. So equals 0.5 plus 0. Okay. So that's the first one. So anything between 0 and 0.5 will be heads. And then on tails, it will always equal the following cumulative probability. And you can even drag this down. That'll be 1. So 0.5 plus 0.5 is 1. So basically what this says, anything between 0 and 0.5, that'll be heads. Anything between 0.5 and 1 will be tails. Okay. All right, so payoff, let's make heads equal 0 and tails equal 1. Just to make it easier. You can put heads being 1 and tails being 0. You can even put heads, the word heads and the word tails here. It's just easier if we do it numbers, okay? So that's the first step of the Monte Carlo simulation. Next step is to assign your random numbers. Again, we're dealing with probability, so we just use the regular random numbers. So equals RAND. That'll give you a random number between 0.38 or between 0 and 1, which is 0.38 in my case, and then you can fill that down. You will have different random numbers than me. Basically, because we're doing a random number generator, the odds of us having the same random number is very, very slim. If it does happen, we should probably play the lottery. Okay. So now the hardest part of this is the VLOOKUP formula, but basically we want to look up this random number in this case in this table array and then return the payoff. Okay, so it's going to look up 0.46. It's going to look up that in between 0 and 0.5. So then it will give us a heads or a 0 here. So that looks like this. Equals VLOOKUP. Looking up that random number, comma, in this entire table array. And let's make that an absolute reference. Hit F4 on your computer if you have it. I don't have, I'm using a laptop, so I don't have F4, so I'm just going to have to type in manual in here. So that's the table array, comma, column index number. Remember, that's what we want displayed. In this case, we want 3 displayed because we want the payoff displayed. So you put 3. And then press enter. All right. So it's going to look up that 0.33 in between 0 and 0.5, and that would give you a heads. Okay, let's fill that down. Nope. Somehow sorry, I didn't mean to put the dollar signs in front of the H and 3. Delete those because we don't want an absolute reference on those. So delete those. It should be just an absolute reference on the table array. Okay. Let's fill that down again. So again, look up VLOOKUP H3 in this case, comma, the entire table array with the absolute reference, comma 3, and it'll give us our simulation here. So again, looking at it just to make sure everything's correct, 0.51, 0.5, and 1, that would give us a tails or a 1, and there's your tails. Okay. There's a couple of ways you can kind of analyze this. You can do an average, so equals average. You can average all these numbers. So 0.7 looks like it's the tails is kind of weighing heavy on this simulation. But if you run it lots of times, you're going to be close to 0.5 just because it's going to do the probability there. But if you want to count how many heads that are there, again, that's using count if function. So equals count if. Range is going to be here. Criteria is comma. Let's count how many heads. So let's do parentheses 0. Okay. So count if that range, comma 0. So that's going to give us how many heads show up there. Okay. That looks like this again. Count if this table range, comma quotation mark 0. So it's going to count 6. It'll give you 6. Okay. All right. So that's the basic Monte Carlo simulation using a coin flip. Okay. I would save this just so you have it, but we're going to move on to a dice throw, which is basically the same thing, and I don't even have to change any of this stuff except for this section over on the left. Okay. So if it's a coin flip, you're going to have 1 through 6 numbers here because you have 6-sided dice. Okay. Don't worry about this line. You can leave it there. It's not really affecting anything. You can take it out if you want, but it's just a line there. Okay. The only thing different is that the probability of flipping a number on a coin is 1 out of 6, right? So it's equals 1 divided by 6. And it's going to be like that all the way down. Okay. See how if we fill this out like a formula, we've already have it filled out. Okay, so 0 to 0.16 would be a, let's say 1. We want the payoff to go all the way to 6. I'm going to fill that down, fill series. Okay, 0 to 0.16 will be a 1, 0.1667 to 0.13 will be a 2. And if you fill this out correctly, all you have to do is fill that down, and it will automatically fill this out. Just to make sure that you're correct, you got to start with a 0 and then end with a 1, because that's the probability distribution, and you already have everything filled out already. Okay. The other thing you have to change is, since we only had a 2 heads or tails, this has 6 numbers, you'll have to change this reference here. Okay. So we're going to look up all these values here. And again, we have to make these an absolute reference because we're going to fill them down. We don't want Excel to move from those. Okay, just fill that down. Again, that's what the formula looks like. If you look up H3 in that entire table array, absolute reference, comma 3. That will simulate a dice throw. And say if we wanted to count how many 4s there are thrown, count if, just change our formulas to 4. See, if you look in here, your 4 will show up and it will count it as a 1 here. So there's 1 4 thrown. Again, every time you press enter on this, it'll change the numbers. Don't worry about that, because everyone's going to have a different solution because you're different random numbers. Say if I wanted you to do a running calculation of the amount of 4s you throw, you can just do count if these the same formula, and then just divide by 10, because that's the number of trials we've run. So every time you click on this, it will actually run the probability of running a 4 or throwing a 4. Okay, so this is 40% or 4 out of 10. We have 1, 2, 3, 4. That's 4 out of 10. Okay. So that's kind of like the non-business side of Monte Carlo simulation. It just kind of gives you a way to simulate a random occurrence with different payoffs. Again, I don't know if this might help you on some sort of games that you play with cards. Instead of having cards, you can just use this. Or if you're doing a game with a coin, you can do this as well. Okay. All right, so let's just X all this out and start over, because we're going to do an example that has more kind of a business aspect to it. So I'm just going to clear all the stuff out. You can save this if you like, but it's not too hard to recreate. Okay. So this is a Monte Carlo simulation again, but we are going to actually use this simulation in a bigger simulation, so it will be just one step in the entire kind of process here. So I'm just going to clear all these out, and then we're going to move on to a new example. Excuse me. All right. So example 2. It's a manufacturing example. Monte Carlo simulation can be actually used to figure out how many defective items you might have. And you can actually take that and use it to put in a QC kind of plan, to where, you know, if you simulate and you have 1 out of 100 products that are going to be defective, then you can say this is how many times the QC manager has to check the exact product. But here's the example. It's Mother Earth Brewery, which is actually in Kinston, and hopefully they're not underwater, but it's a great place if you ever want to go. Mother Earth Brewery has bought a new bottling machine and has asked you to analyze the number of defective bottles they need to account for. They ordered 1,000 bottles of, it's supposed to be 1,000 bottles a month, and the manufacturer quotes the following probabilities with the number of defective bottles. How many bottles do you think they should order? If they can return the bottles for a refund of $2 per bottle, how much money should they get back per month? Okay, so we have probabilities here, and we have defective bottles. We have a 10% probability of 40 defective bottles, 30% probability of 50, and 60% probability of 76 defective bottles. So we're going to set it up exactly like we did with the coin flip and dice row. We're just using more of a business example here. All right, so this will be defective bottles. And we'll put our probabilities right here. Right. See if we can get these on two screens. All right, so we have 40 defective bottles, and we have 50 defective bottles, and we have 76 defective bottles. Probability of 40 defective bottles is 10%. Probability of 50 is 30%. And probability of 76 is 60%. All right. The probability of lower range, remember you got to start with 0. And then cumulative probability, you're going up by the probability of the first occurrence, in this case, it's 40. Next one, you start with the previous cumulative probability. Then again, you can just fill this down. You're going to go up by the next probability. That's taking the 0.3 and adding it to the 0.1. Then you can just fill that down, and it'll automatically fill that out for you. So checking our work, we started with 0, and we ended with 0. Okay. Payoff. In this case, it's not really a payoff. We can just, you can leave it as payoff if you want. You can just put defective bottles as well. And this will be 40, 50, 76. Okay. All right. So we have that set up already. Now all we have to do is put in our random numbers. So again, they're probabilities, so equals RAND. And we're going to fill that down. Okay, again, RAND will just give you a number between 0 and 1, and we're just going to fill that down to do 10 trials. All right. Next part is our VLOOKUP. We're going to look up our random number in this table array, and then we want the third column to be displayed. So we're just use that third column there. So equals VLOOKUP. This is why we learned VLOOKUP early on. H3, comma, this entire table array. And we're going to put $ signs in front of the C, $ signs in front of the 3, or you're just going to put F4, but I don't have it on this laptop. Comma, we want the third column displayed. So we want the amount of defective bottles. Again, looking up that H3, which is the random number in this entire table array, we want the third column displayed, so that's comma 3. Press enter. We look at 0.04, or almost 5%, is between 0 and 10%. So there's 40 there. So we can fill that down. And there you go. So just checking our work. 0.94 is between 0.4 and 1. You have 76. 76 here. Okay. So it looks like it's running how we want it. We had some questions associated with it. It asked how many bottles do you think they should order. So if they order 1,000, and let's say let's do an average here. So they normally order 1,000, but they get, let's say on average, 68.2 defective bottles, then maybe they want to order 69 bottles just to make up for that defective bottles, okay? Yours will be different because your numbers will completely change, but that's kind of how you solve that question. The other one is how much should they get back per month if they can return the $2 for each bottle. So I just took an average here, and let's say let's put a return here. We can just take that average, multiply it by $2. And based upon this simulation of just 10 random numbers, we should get a return of $126 per month. Okay. So that's kind of more of a business-like examples. That's just one of the ways you can use Monte Carlo simulation. We'll do another example in class on Wednesday for face-to-face, and then the online class you'll see the example on Thursday or whenever you watch the recordings. But that's Monte Carlo simulation in a nutshell. It's the first step of other simulation methods we'll be using. But we will get into more simulation coming on Wednesday or Thursday. If you have any questions, feel free to email me. I have been a little slow on emails because I was away on a business trip, and I just got back at like o'clock in the morning this morning, so I'm a little bit slow, but I'm catching up, and I will get back to you. Remember that your homework is due on Monday, which is today, at 11:59 p.m. Okay? And then your case study for face-to-face is due Wednesday at 11:59 p.m. And for your online class is due on Thursday at 11:59 p.m. Okay? All right. Thanks, guys.